A function is called an even function if it has symmetry with respect to the y-axis. This means that you can fold an even function along the y-axis and the two sides will match up. So if we imagine a graph that looks like this, okay, having y-axis symmetry means that the piece on the left-hand side is identical to the piece on the right-hand side. And so the visualization is, can you fold along the y-axis and have the two sides match up? And on this graph, yes, you can. So this would be an example of an even function. From an equation, a function is even if f of negative x equals f of x, meaning if you replace x with negative x and simplify, the equation does not change. A function is called an odd function if it has rotational symmetry with respect to the origin. This means that you can rotate the right-hand side of the graph around 0, 0, and it will match up with the left-hand side. Okay, an example of an odd function is this graph. Okay, so again, the visualization is you can take the right-hand piece and rotate it around 0, 0, and it will match up with this piece. So this piece matches up with this piece, and this piece will match up with this piece when we rotate. From an equation, a function is odd if f of negative x equals negative f of x, meaning if you replace x with negative x and simplify, the result will be the original function multiplied by negative 1. Example 3, we have 3 functions, and we are asked to determine whether each of the following functions is even, odd, or neither. So example 3a, we have f of x equals x cubed minus 6x. And so our test is to substitute and evaluate f of negative x, like we did in a previous section. So f of negative x, we want to replace x with negative x, minus 6, replace with negative x, and now simplify. So if I simplify this exponent, if you cube a negative, 3 negatives is still negative, and x cubed is just x cubed. Negative 6 times negative x, 2 negatives will make a plus 6x. Okay, so now you go through 2 questions. First, is it the exact same as it was? No. Next question, if I take what I started with and I just multiply everything by negative 1, will I get this? Okay, x cubed times negative 1 is negative x cubed, and negative 6x times negative 1 is positive 6x. So this is equal to negative f of x. So we would conclude that this represents an odd function. Example 3b, we have g of x equal to x to the 4th power minus 2x squared. So again, we want to evaluate g of negative x, which would be negative x to the 4th power, minus 2 times negative x squared. Negative x to the 4th power, 4 negatives is positive, and x to the 4th power is just x to the 4th power. Minus 2, that's not affected by the squared. A negative squared, 2 negatives is positive, and x squared is x squared. So comparing this to what we started with, it's identical to g of x, and that would mean that this is an even function. Okay, and so if we graph this, we would see that it has symmetry with the y-axis. And our third function, h of x equals x squared plus 2x plus 1. So again, we want to evaluate h of negative x. That'll be negative x squared plus 2 times negative x plus 1. A negative squared is positive, and x squared is x squared. Positive 2 times negative x is negative 2x, and then plus 1. Okay, so it's certainly not what we started with. This is not the same sign. And is it our function multiplied by negative 1? Well, negative 1 times x squared is negative x squared, and we have positive x squared. So I can't multiply by negative 1 and get this function either. So this function would be neither.